Alright, so today we're going to look at multiplying and dividing fractions. This is a little bit, I think it's easier to do multiplying and dividing than it is to add and subtract. You worry less about common denominators, which is nice. So we're going to start with multiplying fractions. So when we want to multiply fractions, it's really easy. We multiply the numerators. And then we multiply the denominators. And then we reduce if we need to, or simplify. So these ones get pretty simple. So 5/7 times 3/5. So I multiply the numerator. So 5 times 3 is equal to 15. 7 times 5 is equal to 35. Now I need to see if I can reduce. So is there something that goes into both 15 and 35 evenly? I look at that and I say, well, they both end in a 5, so 5 must go into each one. So if I divide by 5, 15 divided by 5 is 3. 35 divided by 5 is 7. So you get 3/7 is an equivalent fraction. There's nothing that goes into 3 and 7 evenly, so this is my final answer. Alright, so I also have 4 times 2/3. So remember we talked about in the adding and subtracting fraction lesson that this really meant 4/1. So then I can multiply my numerators again and my denominators again. So 4 times 2 is 8. 8/3 is my answer. Remember we talked about if you're not quite comfortable with reducing improper fractions like this where the numerator is greater than the denominator, you can leave it like this. Otherwise, you can think of how many times does 3 go into 8? The 3 goes into 8 2 times. I've then used 6 of my numerator, so I have 2 left, and I keep my denominator the same. So 2 and 2/3 is the same fraction or mixed number in this case as 8/3. So we can also look at dividing fractions. Dividing fractions is kind of a weird thing because we add one additional step and then it just becomes multiplying fractions again. So it's not a big stretch to divide fractions, and it's not as kind of terrifying as it sounds to divide fractions. It really just becomes a multiplication problem again. So my steps here are to rewrite the first fraction. So whatever the first fraction is, I rewrite that. Then I'm going to multiply by the reciprocal of the second fraction and then reduce if needed. So that's where it turns into a multiplication problem comes in. So for 4/9 divided by 2/3, if I follow these steps, rewrite the first fraction, so 4/9, multiplying by the reciprocal. Now this means we flip the fraction, which means we flip it. So 2/3, when we do the reciprocal, we have 3/2. And then we multiply like we did just before. So across the top, so 4 times 3 is 12. 12/18, or 9 times 2 is 18, so we get 12/18. To reduce that, I say, what goes into both 12 and 18? I want to find the highest number that I can to reduce that. In this case, I look at that and I say, okay, 6 goes into 12 and 6 goes into 18. That's the highest number I can think of right now. So 12 divided by 6 is 2. 18 divided by 6 is 3. 2 and 3, there's nothing that goes into those two things evenly except for 1. So that's reduced, and this is my final answer, 2/3. So the second one, 8/12 divided by 3/4. So following my steps, I rewrite my first fraction. I multiply by the reciprocal of the second. So the reciprocal of the second becomes 4/3. So I just flipped the fraction. That's all reciprocal means, is I flipped the fraction. So then I multiply across the top, the numerators and multiply across the bottom the denominators. So 8 times 4 is 32. And 12 times 3 is 36. These two obviously decrease to something. They reduce to something because it's 32 and 6. So I'm going to start with knowing that they're both even numbers, so we're going to try to divide by 2. So 32 divided by 2 is 16. 36 divided by 2 is 18. I notice that they're both still even numbers, so I can divide by 2 again to keep reducing them. So 16 divided by 2 is 8, and 18 divided by 2 is 9. 8 and 9, if I look at and say, does any number go into both of those evenly? If I start checking, you would notice that only 1 goes into both of those things evenly. So this becomes my final answer. So multiplying is pretty simple. We just multiply across the top the numerators and across the bottom the denominators and reduce if we need to. To divide, I add one extra step and I change it to a multiplication problem by multiplying by the reciprocal of the fraction we're dividing by, and then it becomes a multiplication problem, and it's pretty straightforward again.